Alrighty, welcome back, boys and girls. It's your math man, Mr. Chen, coming to you live from Grant Middle School. And in this video, we're still working on that SOL review guide, and we're now on that 8.12. And so we're going to be talking about everything box plots. Some key parts to understand from this. Again, you're given a set of data, so that means that you have values that go along with a situation. And what a box plot does is it gives you kind of a quick summary of what your data says. So some things to know for this, again, are this. Again, when you sketch that box plot, it mainly points out that 5 number sum or that 5 critical values. Again, from left to right, we're going to say we have our lower extreme, which is the same as the min. We have our lower quartile, which is Q1. We have our median, which is Q2, our upper quartile, which is the same as Q3, and our upper extreme, which is the same as the max. And what do those values mean? Well, they mean this. Okay, very obviously, our min and max, we have our smallest value and our largest value as the min and max. And then when you're talking about the median, that's talking about, okay, I have my list of values from least to greatest. Right in the middle is that Q2, that median. Once you have that split in half, you have your lower half and your upper half of your points or your data points. And so you're saying, okay, of my lower half, what is in the middle? That is going to be my Q1. Of my upper half, what's in the middle? That's going to be my upper quartile or my Q3. Again, it's super simple to understand as long as you practice it out. If you notice, they're split into those 4 parts. Even if they look different sized, that's okay. Again, make sure you know each section is 25% of your data. So even if these parts look a little bit different sized, it does not matter. They still represent 25% of the data. 2 other things to remember as well. When we talk about the range, that's just going to be, so again, range is still the max minus the min. So that's your largest value minus your smallest value. However, your interquartile range, it's talking about that box section. So that's just going to be your Q3 minus your Q1. So it's just talking about the range of your box. All right, so let's remember how to do some of these. So for number 1, it reads this. It says the number of books read by 4 students during each of the last 12 months is summarized in these box plots. Use this information to answer questions 1, 2, and 3. All right, so we're using this box plot here. So it says which student most likely read 9 or fewer books in the greatest number of months. All right, so we have, this is going to be the number of books read. Again, for each of them, this is 12 months, so you don't have to really worry about that. But saying, okay, 9 or fewer. So let's figure out, where's 9 going to be? Well, this is going to be 9 books. I'm going to say 9 books. And so what we can say is, all right, who is most likely? Well, if you notice and kind of trace along, who has the highest percent of books that are 9 or fewer? Well, if you look at the percentages, we'd say, hey, Charles has 50%, so we'd say 50% of Charles is going to be 9 or fewer books. For number 2, it says which student most likely read 14 or more books in those months. So now we can have 14, so let me say 14. So that we're going to say 14 books. Again, kind of trace along and see, okay, who had the highest percentage? Well, I know that this section of 25% is going to go to Amanda. So we'd say Amanda, of course, has 25% of the books was 14 or more. And then for number 3, it says select all the following statements that are true. All right, so for the first one, it says the fewer books read by any student is, or the fewest books read by any student is 0. So what's the min for any student? Well, the lowest amount is 2, so this is false. For the next one, it says the most books read by any student in any month is 18. what is the max for anyone? It's 18, so that would be true. What about the next one? It says the interquartile range for Amanda and Benji is the same. So let's figure out for Amanda what's the interquartile range. So let's figure out for Amanda. So she has 14 to 9. So we have 14 to 9, which is 5. And for Benji, he has 13 to 7. 13 to 7, which is 6. So we know that this is false. Again, it was saying if these are the same, which they're not. For the next one, it says Benji has the widest range in the number of books read. So we're looking at that widest range. And yes, he has from 17 to 2, so that will be true. For the next one, it says Charles and Daniel have the same upper extreme. So let's see. All right, Charles and Daniel, yep, the upper extremes are the same. And then lastly, it says Amanda and Benji have the same range in the number of books read, which is not possible since we said Benji has the widest, so this one is false. Moving on to the back, it has, for number 4, scroll it down very carefully. It says for number 4, the test scores of 4 students in 2 different classes are summarized in these box plots. It has the number of students in each class. What is the difference between the number of students who scored 90 or greater in class 2 and the number of students who scored 90 or greater in class 1? So let's kind of line up and see where we are at. So we're talking about 90 or greater. So let's find where that's at. So we're talking about this value here. And if we notice, how many sections do we have? Well, we have 2 sections on class 2. So class 2 is 50%. So we're saying 50% of 19. And we only have 1 section of class 1, but they do have more students. So we're saying 25% of 28. So let's figure out what these values are. So this is going to be 7. Let me double check using that Eskimos calculator. We said 25% of 28 is going to be 7. And then we have 50% of 19. So that's going to be about 9.5. So it says take the difference of those 2. It's going to be about 3. So we're going to say about 3 students, and we can take 9.5 minus 7. It's going to be about 2.5, which is, since you can't have really half a student, it's going to be about 3. All right. For number 5, it says a runner records the number of miles she runs on each of 9 days as she trains for a 10K race. That is about that's 6.2 miles. If anyone wants to try to run that, good luck running a 5K. All right. On the 10th day, the runner rests and does not run at all. If the box plot is redrawn to include the additional data, which statement comparing the new and old is not true? Oh man, so we got a lot of stuff going on here. All right. So let's have this. So on the 10th day, the runner rests and does not run at all. Okay, so it gives you 9 days, and then the 10th day, it would be 0 miles. So we'd say 0 miles. So that means, we should have a value down here now. So a lot of things are going to change, but let's see what would happen. All right. So the lower, which comparing these 2 box plots is not true. So we're looking for something that's false. All right. So the lower extreme decreased. That's definitely true. So we're not going to include that one. What about the median? Would the median decrease? Yes, it should, because we added another value. What about the upper extreme? Did that upper extreme change? No, it did not, since we are only talking about a value down here. However, the value of the range did change, and so we know that it is there. All right. For number 6, it says which box plot represents the data. So let me actually get piece of paper, that way I have a little more space. Alrighty. Scroll this up. Alright. First step in doing this box plot, I have to order these values from least to greatest. So I have, let's have it like this. Let's have 2. I have 4. Another 4. 5. 6. 6. So let me write what I'm doing. Order values from least to greatest. The reason why we're doing that, we are using a number line, so it has to be in order. Okay, pick up where we left off, crossed out that second 6. We have still another 6 there. We have 8, 9, 11, 12, and 12. All right, so how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 values. All right, so now, what I want to do from that is let's find the median. So let's find first, or actually, you could find the median, you could find the upper extreme, the lower extreme, whatever works best for you. But let's actually find the 5. Let's find 5 critical values. All right, so we're gonna say this. We're gonna say, hey, boom, that's my min, my smallest number. My largest number, even though there's 2 of them, that's still okay. It is still the largest, which is the max. Let's find our median. So that means, since I have 13 values, that means that I'm gonna have 6 on each side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that means that this is, careful now, this is going to be my Q2, which is my median of my lower half. What is in the middle? Well, I have 1, 2, 3, 4, 5, 6 numbers. So that means in the middle here is going to be 4.5, which is my Q1, my lower quartile. And same kind of setup on the upper half. I have 1, 2, 3, 4, 5, 6 numbers in the middle of 9 and 10, or yeah, 9 and 11 is 10, which is my Q3, my upper quartile. All right, so let's kind of find and see what kind of box plot this represents. All right, so looking at B, I am looking at these medians. Looking at B and C, those medians are not good. What about A and D? I can see that the min for A is not right, so we will not include that one. Let's double check the rest of D. We have 12, 10, 6 as the median, 4.5, and 2, so we are good on there. And then for the next one, it says analyze the box plot below to answer questions 7 through 13. So it gives you the box plot, and now we have to say, okay, let's get that 5 number sum from it. So what we can do is this. All right, let's pull out some values here. So it's actually counting by ones. So if you need to, you can fill it in. I personally like to, that way I know what I'm talking about. All right, so what is the upper quartile? That is the same as Q3. So let's have Q3. Actually, let's label these first. So let's have the min is 19, Q1 is 21, Q2 is 24, Q3 is 27, and my max is 31. Okay, my upper quartile, 27. My median is 24. My lower extreme is 19. What's that interquartile range, or the IQR. The IQR, again, is Q3 minus Q1, which is the same as, let's have 27 minus 21, which is 6. For number 11, it says, what's the range? So we have max minus the min. We have 31 minus 19, which is 12. Speaking of 12, what is the lower quartile? This is going to be Q1, which is 21. 21. And then for 13, it says, what is the upper extreme, which is the max, which is 31. Breaking all the stuff. And it says, what percent of data is at 21 or higher? So let's find 21. So 21 is at that Q1. So that means I have 3 sections. So 3 sections, 25% each. Calculate that carefully. That means I have 75% is 21 or higher.